In this session, we are going to learn about Boolean functions or switching functions. Boolean functions are of two types, sum of products and product of sums. Sum of products are also known as SOP functions and product of sums are also known as POS functions. So SOP functions are group of product terms ordered together. Ordered together means it is added together. For example, ABC plus A bar BC plus ABC bar. So here ABC is a product term. Same way A bar BC is a product term. ABC bar is also a product term. So here all the product terms are ordered together. Ordered together means it is added together to get SOP function. Same way, POS functions are group of sum terms AND together. AND together means it is multiplied together. For example, A plus B plus C dot A bar plus B plus C dot A plus B plus C bar. So here A plus B plus C is a sum term. A bar plus B plus C is also a sum term. Same way, this is also a sum term. So here all the sum terms are multiplied together. So this is an example for product of sums and this is an example for sum of products. So Boolean functions are of two types, SOP and POS, sum of products and product of sums. Now in SOP and POS functions, the occurrence of a variable either in complemented or in uncomplemented form is called as literal. Now we will say what is standard SOP or canonical SOP function. If each term in SOP function has all the literals, then the SOP is known as standard SOP or canonical SOP function. For example, ABC plus A bar B bar C plus A B bar C plus A bar B C bar. In this function, the literals are A, B, C, and in all the product terms, all the three literals are present. That means this is an example for standard SOP function. Now if we take one more example here, AC plus ABC plus AB plus BC plus A bar B bar C. Here also how many literals are there? Three literals are there. But in the first term literal B is missing. And here in this term literal C is missing. And here literal A is missing. That means here some of the literals are missing in some of the product terms. So we can say this function is not a standard SOP function. Now, the each term in standard SOP function is called as minterm. So, this is an important term. Each term in standard SOP function. So, term in standard SOP function means that will be product term. So, product term in standard SOP function is called as minterm. Now we will see what is standard POS function or canonical POS function. Here also, if each term in POS function has all the literals, then the POS function is known as standard POS or canonical POS function. Again, we'll see an example here. A plus B plus C dot A bar plus B bar plus C dot A plus B bar plus C dot A bar plus B bar plus C bar. Here also three literals are there, A, B, C, and in all the sum terms, all the three literals are present. So this is an example for standard POS function. But if you see this function A plus C dot A plus B plus C dot B plus C, here in the first term literal B is missing, in the third one literal A is missing. So this function, this POS function is not a standard POS function. Now each term in standard POS function is called as max term. Each term in standard POS function means it will be having the sum terms. So sum terms in standard POS function is called as max term. Now we will see how to write the min terms and max terms for a 3-bit combination. The variables we are taking it as ABC, and remember while writing the min term, 0 should be represented by complement of the variable and 1 should be represented by the normal variable. Okay, 0 should be represented by complement of the variable and 1 should be represented by the normal variable. And also one thing, min terms are the terms in standard SOP function. Terms in SOP functions are product terms. So while writing the min terms, it must be a product term. So we will see here for 0, 0, 0. 0 is considered as what? Complement of the variable. So that is why we are writing it as A bar, B bar, C bar. And we are multiplying here because it is a product term. Now next is 0, 0, 1. For these two zeros, we need to write it as a bar, b bar, and for this one, we should write it as the normal variable c. So for 0, 1, 0, it will be a bar, b, c bar. 0, 1, 1, a bar, b, c. 1, 0, 0, a, b bar, c bar. 1, 0, 1, a, b bar, c. 1, 1, 0, a, b, c bar. 1, 1, 1, a, b, c. Now exactly the reverse we need to do for writing the max terms. While writing the max term, 0 is considered as the normal variable, and for 1 we have to write the complement of the variable. 0, for 0 we have to represent it by normal variable, and for 1 we have to represent it by complement of the variable. And max terms are, what is max term? Terms in standard POS function, and terms in POS functions are the sum terms. So here we need to write the sum terms. Now for 0, 0, 0, 0 should be represented by normal variable, so a plus b plus c. Now for 0, 0, 1, a plus b plus, here for 1 we should write the complement of the variable, so a plus b plus c bar. 0, 1, 0, a plus b bar plus c. 0, 1, 1, a plus b bar plus c bar. 1, 0, 0, a bar plus b plus c. 1, 0, 1, a bar plus b plus c bar. 1, 1, 0, a bar plus b bar plus c. 1, 1, 1, a bar plus b bar plus c bar. Now we will see how to write the minterms and max terms from a given function. For example, the function is f is equal to abc plus a bar bc plus a b bar c bar plus a bar b bar c plus a bar b bar c bar. Now remember, this is SOP function. For the SOP function, this is standard only. For SOP function, the terms are min terms. So min terms, how we are writing the min terms? If it is a normal variable, we should write it as 1. If it is a complement of the variable, we should write it as 0. Now for A, B, C, it will be 1, 1, 1. What is 1, 1, 1? It is 7. Now for A bar BC, A bar BC means A bar. So we are writing it as 0. BC 1, 1. So 0, 1, 1 is 3. Now A, B bar, C bar. A is the normal variable, writing it as 1. Here it is complemented of variables. So 0, 0. So 1, 0, 0 is 4. Now A bar, B bar, C. A bar, B bar, 0, 0, C is 1. 0, 0, 1 is 1. Now A bar, B bar, C bar. A bar, B bar, C bar means 0, 0, 0. That is equal to 0. Now these are the min terms. Now how we are representing the SOP function is f is equal to summation m, sigma m. So sigma indicates the function is SOP function, and the small letter m indicates the min terms. And what are the min terms here? 0, 1, 3, 4, 7. 0, 1, 3, 4, 7. So this is how we are writing the min terms from a given function. Now we will see how to write the max terms from a given POS function. So this is the POS function. The function is standard function because all the sum terms are having all the literals. Now we will write, and remember, in POS function, now we will see how to write the max terms from a given POS function. So this is the given POS function, and the function is standard function because all the sum terms are having all the literals. Now remember, while writing the max term, if the variable is in the normal form, that should be represented by zeros, and if the variable is in the complemented form, we should write it as 1. So here a plus b plus c, all the variables are in the normal form, so we have to write it as 0. So 0, 0, 0, it will be 0. Then here it is a bar plus b plus c. Since it is a bar, we need to write it as 1. Then for bc, 0, 0. So 1, 0, 0, 4. Then next is a plus b bar plus c bar. So 0, 1, 1. That is 3. Then a bar plus b bar plus c. A bar and b bar is in complemented form. So we are writing it as 1, 1. Then c is in the normal form. That is 0. So we got all the max terms here. It is 0, 4, 3, 6. Now the POS function is represented by pi capital M. So this pi indicates the function is POS function, and this capital M denotes the max terms. Now what are the max terms of the given function? 0, 3, 4, 6. So this is how we are representing a function in terms of max terms. Now we will see an important topic, conversion of SOP functions to standard SOP function. So remember, what is standard SOP function? If each term in SOP function has all the literals, then the function is known as standard SOP function. Now these are the steps for converting SOP to standard SOP. First, we need to find out the missing literal in each term. Then we need to multiply the terms having the missing literal with missing literal plus complement of missing literal. Then we need to expand it and reorder and eliminate the repeated terms. How we can eliminate the repeated terms? Because a plus a is same as a. So these are the steps for converting SOP to standard SOP. Now we will see an example here, AC plus AB plus BC. So this is an SOP function, but it is not in standard form. So we are going to convert into standard function. So the first step is to find out the missing literal. So in the first term, literal B is missing. In the second term, C is missing. In the third term, A is missing. Now the next step is to multiply these terms with missing literal plus complement of missing literal. So the first term is AC dot B plus B bar. Second term is AB dot C plus C bar plus next term is BC dot A plus A bar. So we are multiplying missing literal plus complement of missing literal. Now we need to multiply it and reorder. So AC into B, that means ABC plus AC into B bar, AB bar C plus ABC plus ABC bar plus BCA, that means ABC plus A bar BC. Now we can eliminate the repeated terms here. ABC is repeated 3 times, so we need to write only once. So ABC plus AB bar C plus ABC bar plus A bar BC. So this is how we need to convert SOP functions to standard SOP functions. Now we will see how to convert POS functions to standard POS functions. What is standard POS function? If each term in POS function has all the literals, then we can say the function is standard POS function. These are the steps for converting POS to standard POS function. The first step is to find out the missing literal. Then we need to add the terms having the missing literal with missing literal dot complement of missing literal. Then expand and reorder and eliminate the repeated terms. We'll see an example here, a plus b dot b plus c dot a plus c. So here this is a POS function because it is a product of sums, but here in the first sum term c is missing, in the second term a is missing, in the third term b is missing. So we need to convert this into the standard function. So what is the step here? Here c is missing, so we need to add with complement missing literal dot complement of missing literal, that means a plus b plus c dot c bar. Second term is b plus c, we need to add with a dot a bar. Then third term is a plus c, so a plus c plus missing literal is b, so b dot b bar. Now we need to add it and expand it and reorder. So a plus b plus c. Next we'll get a plus b plus c bar. Next we'll get b plus c plus a. In order, if we write, it will be a plus b plus c. Then next is a bar plus b plus c. Then here we have a plus c plus b, that means a plus b plus c. Then next term a plus c plus b bar, that means a plus b bar plus c. Now which term is repeating here? A plus b plus c is repeated 3 times. So we are eliminating that, means we need to write it once. So the final expression will be a plus b plus c dot a plus b plus c bar dot a bar plus b plus c dot a plus b bar plus c.